Dear friends, in this session I want to talk about securing microservices. Microservices, as you know, are independent applications that have its own processes and lifecycle, and they communicate with each other to process a request. Now, how do we ensure that these microservices are secured? That means they do not get attacked, and whatever security we provide to the applications, the same way we need to provide security for each of the individual microservices. Now let's look into some of the details. The microservices architecture expands the attack surface. That means if I have more number of microservices, the attack surface is more. That means it is more vulnerable for attacks. So we need to understand this, that the more number of microservices, the robust should be our mechanism to secure them. Now, how can we do that? Let's see from four perspectives. We need to follow a proper development lifecycle which ensures security as part of the development lifecycle. The second one is we need to have automation for security related tests. The other one is following the DevOps principles in a secured way. That means deployment, building, all those things, not just development, but also the deployment and maintenance in a secured way. And then we need to ensure application level security that we generally provide to our applications. There are specific techniques that we can use. Now, API gateway is one where security vulnerability can happen. Now, what is API gateway? If you see, we have multiple microservices and they are communicating each other. So how do we do, like if this is a user mobile or a user desktop which connects with our set of microservices which define our application, right? So we need to provide one single point of entry to the external users. So this single point of entry is called API gateway, so that the client application don't need to know which service to call, because it don't know whether it has to call this service A, service B, service C. What we can do is we give only one endpoint, which is an external endpoint for the clients, which will call this API gateway, and then this gateway will further understand which microservices to call and then call it. By this way, we will have only one entry point for any of the clients that are connecting to our application. So that is what we are calling here as a centralized entry point. An API gateway serves as a single entry point for requests, enabling you to centralize security controls, authentication and rate limiting. Let's see what is the rate limiting. Now, if this application is getting a lot of requests, maybe created by a bot to pull this down, right? So we need to ensure that the application is not overloaded with malicious attack calls. So what we do in such cases is to limit the rate. That means the number of requests it is getting, we have to limit it. We will set one limit, like per second only so many, like 100 requests per second is the only limit. If more than that comes, then we will not accept it. We will still not process them, so that it is protected for malicious attacks. Can limit the number of requests, which helps to prevent abuse and denial of service attacks. The another thing we can do at a API level, API gateway level, is SSL termination. You know that if any request that is coming from HTTPS, then it is a secured connection, right? So we shall ensure that all the connections terminated SSL at the API gateway level to ensure the clients and services are encrypted. So this is one way to prevent attack on our microservices, provide more security. Now, coming to the next one, we will see authentication and authorization. You know that we should provide authorized access only to the microservices. Not only authentication, we also need to authorize. So let's see how we do it. We can use OAuth 2 or OIDC, which uses a token based standards like OAuth 2 for authorization and OIDC for authentication. JWT is what commonly we use to provide the access to the clients. By using JWT tokens, we can ensure that we only legal parties or only allowed connections are established. We can also provide role based and attribute based access. Now role based means particular roles like admin or super user like that, role based we can provide. And also we can provide some attribute based, like only particular attributes, if the attribute is allowed we will do it, otherwise we will not provide the access. So this way we will provide a granular access. That means we don't provide entire access to everybody. We will control access to some people with some privileges and some permissions to have access to the services. The other one is zero security, zero trust security. What we mean by that is, suppose one request is established and it is secured, we don't take it for granted for the subsequent requests. Each time is new. Each time we want it to be validated, and not only one side but both the sides. So trust means we don't trust second time when the same person comes. The same way, when a request comes from one IP to our service, each time we validate it. Follow the zero trust model, whereas each service requires authorization for every request. This is important, rather than assuming inherent trust within a network. So for authentication and authorization, we can follow JWT tokens, role based access and attribute based access, and then validating and authorizing each of the requests with zero trust security. The third one we can do is mutual TLS. So TLS provides a secured connection between the two parties, between the two microservices. Now when we have provide mutual TLS, that means A and B, suppose these are the two, we need to establish a connection between these two. A asks for B's certificate and B asks for A's certificate. A validates B and B validates A. A validates B, saying that is it the right service, am I calling, and B validates A, that is it the right requester. So ensuring secure communication between services by implementing mutual TLS, where authentication both the client and the server. Then we also provide identity management. Each microservice should have its own unique identity, often handled by a centralized service provider or a service mesh. So identity management here talks about that every microservices has its own identity, so that the identities are clearly established and they are easily understood and verified. Now we go to the next point, where we provide secure service communication like TLS encryption. We provide encryption for the data that we are exchanging between the two microservices. Encrypt all the traffic between services using TLS to prevent man-in-the-middle attack to ensure data confidentiality. So when we say A and B, the content that goes from here to here is encrypted with some key, and then this is decrypted here with the same kind of key. So both the parties know what is the key during the TLS, and then they exchange the information in a secured way. We also use a technology like service mesh, which like Istio or Linkerd are the two providers of service mesh technology. We use service mesh to manage and secure communication between microservices. As you know, service mesh provides the protocol, the technology outside the business logic. Like we have A microservice, B microservice. Developers focus on writing the business logic, and then when it is deployed in a service mesh, the communication between these two is taken care by service mesh, so that developers don't have to focus on the infrastructure layer, and then this is managed by service mesh, and service mesh goes well with Kubernetes. So it's much easier for Kubernetes deployed applications to use service mesh for ensuring the connectivity and the security built across the different microservices. Now the fifth point we can talk about is data encryption. We touched upon this point in the previous, and the storage security. Let's see, encrypt data at rest and in transit. So at rest means where it is saved, and at transit means when it is sent from one service to another service. So sensitive data should be encrypted when stored and transmitted. Database access control. We know that we shall provide access control to the database. Limit the database access by assigning specific roles. and privileges to microservices that interact with the database. So last time we have seen that one a microservice to microservice communication, we provide role-based access to the functionality of the microservice. Now apart from that, we can also provide, if this microservices has a database, we can also provide one more granularity to connect with the database, like who can access, what can they do on the database, like what principle, what privileges they have, can they delete something or can they add something or can they only view something. So by providing database access control, we can limit the attacks and make it more secure. We also need to maintain the secrets. Secrets are the passwords, right? So if we store these passwords in a .text file or some configuration file, they are easily exposed. And since we have hundreds of microservices, each of them have their own access and passwords and databases. It's a big list of passwords, right? So we use a password management tool or secret management tool. HashiCorp's Vault is a good one, or AWS Secret Manager is another tool that provides managing the secrets to securely manage API keys, database passwords, and encryption keys. So this way we'll add one more level of security by keeping the data in a secured way by encrypting, then providing controlled access to the database, and then maintaining the passwords in a secured password management tool. Then we talk about security in the software development lifecycle. This is where the development process is also ensuring security. So the coding should ensure secure processes, ensure developers follow secure coding practices like validating inputs, sanitizing outputs to prevent vulnerabilities. So when developers write some code, if this is a text box, an input field, whatever is entered here need to be validated. And then if there is some value that we are sending out from one microservices, we need to see what it contains, what data is it going, is there some secret information going, is there some personal identified information that is going out. So we need to sanitize the input and output, like SQL injection, cross-site scripting can be prevented by following secure coding practices. Now automated security testing. So this is what I was mentioning in the beginning, that the testing should include some automated security tests. Integrate security testing into the CI/CD pipeline. Use tools like static analysis and dynamic analysis and dependency scanning to identify vulnerabilities early. Here static analysis talks about, I have a lot of code, right? So many files, so many packages, and so many lines of code in each of them. It may contain some vulnerable code. Maybe if it has some open source stuff, then it can still have some vulnerabilities. So we need to scan this code before we compile it, and maybe we deploy it and build the application. We'll scan it that's called static analysis. When we scan the code, identify any vulnerabilities and fix them. So one is static code analysis. The second one is dynamic code analysis. So what we mean by dynamic code analysis is that once the application is built, we can run the vulnerabilities on top of it, so that after the code is built, we can still identify if there are any vulnerabilities. So both the static analysis tools and dynamic analysis tools need to be added, automated to be tested for each of the build that we do for our microservices. Then we need to do proper code reviews and then auditing the code. Auditing the code means who has accessed the code, who have modified the code, and what kind of audit controls that we have for modifying and updating the code or adding the code. So code review should be done with a security in mind. We should not just look for the functionality. We should also look for non-functional stuff, like security is one and also performance is one, and we may identify some unnecessary code which we can remove as part of the code review. So all the developers need to learn how to review code properly, and they should do regular code reviews. So conduct security code reviews, regular security code reviews and audits to ensure no new vulnerabilities are introduced. We'll see the next one, which is network security isolation. So here we will see segmentation of the network. We use network policies to segment services. What we mean by that is, suppose if these are some microservices, these are in one network, and I have another network where I have some more microservices. We need to have, if we don't need to have any connectivity, or we need to have a proper policies to segment them separately. So Kubernetes network policies can restrict traffic between namespaces and pods. This is also one way where we can utilize the same resources, same hardware for different customers by providing no access to others' services. Right? So we need to use network segmentation to effectively use the resources and also to prevent unauthorized access. We shall use firewalls and IP whitelisting. So use firewalls to restrict access to only trusted IPs and whitelisted services. Only expose essential endpoints externally. This way, in our configuration file, we will say what is inbound, what is outbound, and only inbound will be allowing, and only outbound we will be allowing to send the data and to receive the data. Right. So by doing this whitelisting and then providing firewalls, we'll be able to secure our microservices. Now private subnets host services, sensitive services and databases in private subnet to limit access to internal network as well. So if we have some secured services that are very sensitive, we need to host them in a private subnet. The next point we'll talk about logging, monitoring and alerting. This part of the observability where we have discussed that observability can provide the state of the application. Similarly, we will see utilize logging, a centralized logging mechanism to use so that we can provide more security. Say ELK stack or Splunk, these are log aggregator services. Now what they do is, if I have multiple microservices, from all of them they expose an endpoint, and this is my log aggregator. All of them push the logs here. From here I'll further analyze either with some other UI or some other technology, or it may be an integrated UI where I can analyze and read the logs. So by doing a centralized logging, by aggregating logs from all microservices, we will be able to detect unusable activity, like maybe same microservices called again and again and again, or maybe some unusual activity is going on. So we can identify them from logging by analyzing the logs from the centralized logging system. We need to audit the logs. Again, auditing talks about like who has logged in, how many attempts. Sometimes if an attacker want to log in, they change the password, they change the username, and then automate this process and try to log in. So these kind of login attempts can be found out using auditing while we audit the logs. Now permission changes or access to sensitive data, these all can be identified. Say for example, if one developer have modified permissions of any microservices, we can find it out from the logs, like okay, it happened, the permission has changed by so and so. So by auditing the logs, we can identify any vulnerabilities got introduced into the application. Now alerting is a mechanism where if any metric is crossed or any threshold is changed, then we'll get an alert. So we can set up alerts to monitor suspicious activities such as repeated authentication failures or unexpected spikes in traffic or requests from unauthorized IPs. So we can get an alert if something malicious things are happening. We can configure our alerting system to send us an alert, maybe an email or maybe some other mechanism to say there is something going on in a unsecured way. Right. Now let's see the next one, which is rate limiting and throttling. As we discussed during API gateway discussion, API rate limiting limits the number of requests per user or service to prevent abuse and protect against denial of service attacks. So we limit the number of requests that we take. And circuit breaker and retrace. So here the concept of circuit breaker and retrace may be familiar to all of you, but let me give a brief explanation. So I have one microservices A, and I have another services B, and I have another service D. Now A calls B, B calls C. So suppose this is the scenario. Now A has sent a request to B. Now it waits for a response from B, but B is not sending any response. the problem can be with B or can be with C, which B is also waiting for C, right? So if C has failed, then B cannot send a response, so A cannot receive the response. Now if this kind of thing happened, then what do? We need to stop this, right? So that again we will try it. So what we do is we break the circuit. Break the circuit means we say we ignore this flow and then we restart the flow. So how it happens? A calls B and then waits for say 1 millisecond, and then um, sorry, say 5 milliseconds, and if we don't respond, then we will retry it. So maybe we retry for 3 times. So what happens if 3 times also it didn't respond? Then we can say something is wrong, right? So we break the circuit and we do some retries. So implement circuit breaker to prevent cascading failures from one service to another service to another service, and avoid overloading services by limiting the number of retries. Like we will only limit to 3 times retrying or 5 times retrying, so that it won't keep on retrying unlimited number of times, right? So we use these techniques to prevent and recover from overloading and recover from a cascading failure scenarios. Now let's go to another point where we talk about security policies and compliance. Now security policies define and enforce security policies. Define and enforce security policies such as password policies, like every 3 months once we have to change the password, 3 months, or we have to say password should be minimum of 12 characters length. It should have alphanumerical and special characters. So all these policies need to be defined and enforced to follow. Then access control rules and data handling procedures. So all these policies, security policies, need to be followed. Then compliance. So this compliance, these policies we set as a development team or an organization level, whereas compliance is from external agencies like GDPR or HIPAA. So these kind of compliances need to be followed so that users trust our application and we protect the data of the users. So ensures your system complies with relevant standards and regulations by following best practices in data handling, encryption, and auditing. Now we'll see another couple of points. Runtime security and vulnerability management. So here it is runtime. So once we build the application and deploy it, and then later some attackers can identify, if we use some open source code, attackers can identify some vulnerabilities and create some viruses, right? So what we have to do is to do a runtime protection. So let's see, container level security. Use image scanning to detect vulnerabilities in container images. So these are Docker containers, right? So once we deploy an application, we call it as an image, and this image can be scanned to detect if there are any vulnerabilities that are there. So vulnerabilities are like set of attacks we already know, which are predefined, and then against this list we verify our microservices image or our application image. So these images, and keep them updated with security patches. Only use trusted images from verified registries. Then it's like we use our antivirus software. When a new vulnerability is identified, antivirus gets updated. This can prevent it from damaging our application. Similarly, runtime protection. Employ runtime security tools like Falco or Aqua Security to monitor and protect containers during runtime. So this is important. During runtime, when applications are running, we can detect unusual behaviors, we can enforce some policies, and then we can use some security tools to identify and protect our microservices, identify vulnerabilities and protect our microservices. Then isolation is a technique where isolate containers and run them with least privileges, minimizing the attack surface by restricting capabilities and avoiding running services as root. So usually if we want to run one service, run it as a root. But if you create a policy, if you create a role and then access grant only to that role, then you will be providing more security, right? So you can also minimize the attack by restricting the capabilities and who can do what, which role can access what functionality. Okay, so and isolate each of the microservices as much as possible so that one attack will not lead to the attack on the others. Now let's look at the final one. We'll see regular security reviews and penetration testing. Penetration testing is an important testing where we deploy the application and we use some tools to run tests on this tool, like a user is typing, or a automated script is running to log in to unless to grant to gain access or control onto the service, onto the services. So we use penetration testing. There are tools and there are companies who are specialized in penetration testing, and using these penetration testing we can prevent any unauthorized use. Let's see, security audits. Conduct periodic security audits to review and improve your security measures. This includes reviewing the access control, configuration management, and network policies. Now, penetration testing. Regularly perform penetration testing on your microservices to discover vulnerabilities and test the effectiveness of your security measures. So these are the points we have. I would also like to add one more, like threat modeling. When we do threat modeling at the time of development, at the beginning of the development or design phase, so that you will have the scenarios need to be covered as part of security, and you can do it at the design time itself, so that your development cost will be easier to manage and you will have a secured application. So start following the best practices as discussed here, so that your applications are more secured and you will be able to run a secured microservices environment.